So in our warm-up, we saw an example where we had a polynomial being raised to an exponent up here. So it was to the power of 2. So that was easy to deal with. We could just write it out as 5x plus 2 times itself twice. The problem would happen is if this question was changed and it wasn't raised to the power of 2, but it was raised to the power of 7. And so now we would go off, and the only way we know how to deal with this is to write it out 7 times. And then do we have a product rule for when you're multiplying 7 of these? Well, no. And rainbowing before you differentiate isn't much better because you'd have to rainbow it 7 times. So this introduces the problem for today. So you have a worksheet that you can look at, and it's called the power of a function rule. So what happens when we have a function with being raised to some exponent that we don't want to expand. So you see on the top of the worksheet is an example just like that. Here's one. Now it's a trinomial raised to the power of 5. We don't want to have to expand all that. So we'd like a rule to deal with that. And the power of a function rule is right here. So it says if u is a function of x and n is a positive integer, then we can take the derivative of the u to the power of n part first, then differentiate the actual function. So when you read it right there, it's a little bit wordy. In sort of layman's terms here, it says the derivative of the power times the derivative of the function inside. So it's best, instead of trying to explain it in abstract terms, it's best to actually do it with an example. So we'll come back to this problem afterwards. We'll try and deal with this one here. A little bit easier. So if we have a function that in this case is 7x minus 2 to the power of 4, if we were to find the derivative, we pretend that it's just something to the power of 4. So let's just pretend it's u, for example, to the power of 4. So the derivative would just be 4u to the power of 3. Then you multiply it by the derivative of the inside. Let's see how that actually works when we actually take the derivative. So I'm not going to scratch it out and call it a u. I'm just going to keep it there. So it's something in brackets to the power of 4. So we use the power rule, and we know it's 4 times that thing in brackets raised to the power of 3. If it was a u, there'd be a u. But it's not a u, it's another function. It's 7x minus 2. But that's not the only part. You need to then multiply it by the derivative of the inside. So now you just look inside, treat it like its own little function, and take the derivative of it. The derivative of 7x minus 2 is just 7. And that indeed is the derivative. But again, we'd like to tidy things up. You notice that we have a times 4 and a times 7. Those can be combined to make 28 7x minus 2 to the power of 3. We can't rainbow this 4 because it's being raised to the power of 3, and BEDMAS tells me I have to do exponents before I multiply. So I can't rainbow anything there, so that doesn't help us. Same with after I get the 28, I can't rainbow the 28 in because, again, it's being raised to the power of 3. So that's as far as we can go, and that is the derivative. So again, our idea is you take the derivative of the outside and the derivative of the inside. One of the examples I like to use is like the Russian doll analogy. So I don't know if you've seen those Russian dolls. They're the ones where you have got a doll shape. It's kind of a big one, and you open it up, and inside is another doll that looks just like it but smaller. And then you open that one up, and there's another doll. And open that up, and there's another doll. To do this, you got to deal with the outside doll first, leaving the inside alone, do its derivative, then go inside and treat it like its own little question, and then go further inside, and we'll see this pop up a number of times. So in the second example, B, we have h to the power of x, and this time it is 5x squared plus 4, all raised to the power of 5. So we're going to take the derivative of the outside, ignoring the inside. It's something to the power of 5, which is 5 something to the power of 4. And then we'll write down what is there exactly as we see it. We don't differentiate yet. This all stays the same. But then we go times the derivative of the inside. And in this time, the derivative is going to be, well, derivative of 5x squared is 10x plus 4. So we're just left like that. Again, we can simplify. We have a times 5 and a times 10x. That can be simplified into 50x times 5x squared plus 4, all raised to the power of 4. And that's as far as we can go. So it's not on the sheet, but I'd like you to now try back up to the original question. So let's try this one. 4x squared plus 3x minus 7 all raised to the power of 5. So if you could just pause for a second, we'll give everyone a chance to try that on their own, and we'll come back and see the answer. Okay, hopefully you've had a chance to try it on your own. So the derivative, even though the inside is a big number, it doesn't matter. We still deal with the outside first, so it's to the power of 5, so it's something. 5 times something to the power of 4. That something is exactly what we see in there. Times the derivative of the inside. And the inside is another polynomial, so we've got the derivative of 4x squared is 8x. The derivative of 3x is 3, and the derivative is minus 7 is 0, so that's gone. Can we simplify this further? Sure. Same multiplication. We've got a 5 times this time, so it's a little bit of little mini rainbow we got to do. That 5 times the 8x is going to be 40x, and the 5 times the 3 is 15. Since I'm doing a little mini rainbow, that's got to be its own part in brackets. And then this whole part here is just left alone, 4x plus 3x minus 7, all raised to the power of 4 this time. And that would be the derivative of the top. And again, you can see that's definitely much easier than having to expand that big trinomial 5 times.